The Evans bender has received positive feedback for saving significant time on jobs. Electricians have reported it's a great investment reducing man-hours. It is considered a must-have tool for those who work with electrical metallic tubing, known for being quick, accurate, and durable. Some users shared they used to spend hours bending by hand, which is now done in a fraction of the time using this bender. The price is seen as a bit high, but many believe it pays for itself over time. Some users mentioned a learning curve, but note that once you get the hang of it, it becomes easy to use. Portability has been mentioned as not ideal. Overall, the Evans bender seems well regarded among electricians, praised for its speed, accuracy, and durability. The price is a consideration, with many users finding it worth the investment due to time savings. If you frequently work with 1/2 inch to 1 inch EMT, this could save you significant time. The cost is $1150, and you should weigh that against the potential time savings and increased productivity to determine if it is a worthwhile investment. It is not as portable as other bending tools, so if portability is a major concern, consider other options. Consider renting before purchasing to see if it meets your needs. Practice using the bender in a safe environment before using it on the job. Use a lubricant to ensure smooth bending and prevent damage to the tool. When evaluating a tool such as this, it's important to consider the types of bends typically performed. If the majority of bends are simple offsets or 90-degree bends, a more basic bender might suffice. However, if the work involves complex bends, saddles, or segmented bends, the Evans bender's capabilities could justify its cost. Consider the volume of work and project size. For small projects or infrequent use, the investment in a specialized bender may not be necessary. However, for larger projects with repetitive bends, the time savings and increased accuracy can significantly improve efficiency and reduce material waste. Durability and maintenance should also be part of the decision. Determine the Evans bender's reputation for reliability and ease of maintenance. A tool that requires frequent repairs or has a short lifespan may negate the initial time savings. Research the availability of replacement parts and the cost of maintenance. Another factor is the ease of use and training requirements. Even with a sophisticated tool, proper training is essential to ensure accurate and consistent bends. Evaluate the availability of training resources and the learning curve associated with the Evans bender. A tool that is difficult to learn or requires extensive training may not be the best choice, especially for less experienced electricians. You may also want to look into compatibility with different types of conduit. While the focus is on EMT, consider whether the Evans bender can also be used with other types of conduit, such as rigid metal conduit or aluminum conduit. This versatility can increase the tool's value and justify the investment. Evaluate the power source requirements. Some benders require a specific voltage or amperage, which may not be readily available on all job sites. Consider whether the Evans bender is compatible with the available power sources or if additional equipment, such as generators or transformers, will be needed. Check for safety features. Look for features such as overload protection, emergency stop buttons, and clear operating instructions. Prioritize safety to prevent accidents and injuries on the job site. Before making a final decision, compare the Evans bender with other similar benders in the market. Consider factors such as price, features, and user reviews to determine which bender best meets your specific needs and budget. Also, investigate the warranty and return policy. A reputable manufacturer will offer a warranty that covers defects in materials and workmanship. A flexible return policy allows you to return the bender if it does not meet your expectations. Another thing to look into is the availability of accessories and attachments. Determine whether the Evans bender can be used with various accessories, such as different size shoes or bending tables. These accessories can expand the tool's capabilities and make it more versatile. Check for compliance with industry standards. Ensure that the Evans bender meets all applicable industry standards and regulations, such as those set by the National Electrical Code, or NEC, and Underwriters Laboratories, or all. Compliance with these standards ensures that the tool is safe and reliable. Ask for references and testimonials. Contact other electricians or contractors who have used the Evans bender and ask for their feedback. Their experiences can provide valuable insights into the tool's performance and reliability. You might also want to consider the long-term cost of ownership. In addition to the initial purchase price, factor in the costs of maintenance, repairs, and replacement parts. A bender with a lower initial price may end up being more expensive in the long run if it requires frequent repairs or has a short lifespan. Before purchasing any electrical equipment, it's crucial to understand the relevant electrical codes and safety regulations. These codes, such as the NEC, provide guidelines for safe and effective electrical installations. Ignoring these regulations can lead to hazardous situations, including electrical shocks, fires, and equipment damage. One of the most important aspects of electrical safety is proper grounding. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Make sure that all electrical equipment is properly grounded and that grounding connections are secure. Another key safety measure is using ground fault circuit interrupters, or GFCIs, in areas where there is a high risk of electric shock, such as bathrooms, kitchens, and outdoor locations. GFCIs monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. Make sure that these devices are properly sized for the circuits they protect and that they are in good working order. Electrical wiring must be properly installed and maintained to prevent insulation damage, loose connections, and other hazards. Use the correct size and type of wire for each circuit and ensure that all connections are tight and secure. Regularly inspect wiring for signs of damage and replace any damaged wiring immediately. Electrical panels should be properly labeled to identify the circuits they control. This makes it easier to locate and shut off power to specific circuits when performing maintenance or repairs. Keep electrical panels clean and free of obstructions. Always use appropriate personal protective equipment, or PPE, when working with electricity, including insulated gloves, safety glasses, and appropriate clothing. Avoid wearing jewelry or other metal objects that could conduct electricity. Before working on any electrical circuit, always de-energize the circuit and verify that it is de-energized using a voltage tester. Never assume that a circuit is de-energized simply because the switch is turned off. When working with electrical equipment, follow all manufacturer's instructions and safety precautions. Use tools and equipment that are in good working order and that are appropriate for the task at hand. Never attempt to repair or modify electrical equipment unless you are qualified to do so. If you are not comfortable working with electricity, hire a qualified electrician to perform the work. Working with electricity can be dangerous, and it is always best to err on the side of caution. Regularly inspect electrical systems for signs of wear, damage, or corrosion. Address any issues promptly to prevent them from escalating into more serious problems. Keep electrical equipment and wiring dry and free from moisture. Moisture can cause corrosion, short circuits, and other electrical hazards. Avoid overloading electrical circuits. Overloading can cause wires to overheat, potentially leading to fires. If you need to add more electrical devices to a circuit, consult with a qualified electrician to ensure that the circuit can handle the additional load. Use surge protectors to protect sensitive electronic equipment from voltage spikes and surges. Surge protectors can help prevent damage to computers, televisions, and other electronic devices. Educate yourself and others about electrical safety. The more you know about electrical safety, the better equipped you will be to prevent accidents and injuries. Encourage others to learn about electrical safety as well. By following these electrical safety tips, you can help create a safe environment for yourself, your family, and others. Electricity is a powerful force that must be treated with respect. Consider the availability of local support and service. Determine whether there are local dealers or service centers that can provide assistance with maintenance, repairs, and troubleshooting. Local support can be invaluable in minimizing downtime and keeping the bender in optimal condition. Before making a purchase, consider the overall return on investment, or ROI. Calculate the potential time savings, increased productivity, and reduced material waste that the Evans bender can provide. Compare these benefits to the cost of the bender to determine whether it is a worthwhile investment for your business. Stay informed about the latest advancements in bending technology. As technology evolves, new and improved benders may become available. Stay informed about these advancements to ensure that you are using the most efficient and effective tools for your electrical work. The NEC provides tables, such as Table 310.15, that specify the allowable ampacities of insulated conductors based on factors like conductor size, insulation type, and ambient temperature. These tables are essential for ensuring that conductors are not overloaded, which can lead to overheating and fire hazards. Voltage drop is another critical consideration in electrical installations. Excessive voltage drop can cause equipment to malfunction and reduce the efficiency of electrical systems. The NEC provides guidelines for calculating voltage drop and recommends measures to minimize it, such as using larger conductors or reducing the length of the circuit. Short circuit current rating, or SCCR, is the maximum fault current that an electrical component or system can safely withstand without sustaining damage. It is essential to ensure that all electrical components have an SCCR that is equal to or greater than the available fault current at their point of installation. This helps prevent equipment failures and electrical hazards during short-circuit events. Arc flash is a dangerous phenomenon that can occur when there is a short circuit or fault in an electrical system. The intense heat and energy released during an arc flash can cause severe burns, injuries, and even death. It is essential to conduct arc flash hazard assessments and implement appropriate safety measures, such as wearing arc-rated clothing and using insulated tools to protect workers from arc flash hazards. Equipment grounding conductors, or EGs, are used to provide a low-impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse and preventing electrical shock. Each EC must be properly sized and installed to ensure that they can safely carry fault current. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. Bonding helps to minimize voltage differences between metal parts, reducing the risk of electrical shock. Equipment bonding jumpers are used to bond metal parts of equipment together, while system bonding jumpers are used to bond the grounded conductor to the equipment grounding conductor at the service entrance. Grounding electrode conductors, or GECs, are used to connect the grounding system to a grounding electrode, such as a ground rod or a metal water pipe. The GEC provides a path for fault current to flow to ground, helping to stabilize the electrical system and prevent electrical shock. The size and type of GEC must comply with the NEC requirements. Separately derived systems, such as generators and transformers, require their own grounding systems. The grounding system for a separately derived system must be installed in accordance with the NEC requirements, including the use of a system bonding jumper and a grounding electrode conductor. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dusts. Electrical equipment installed in hazardous locations must be specially designed and certified to prevent ignition of these materials. The NEC classifies hazardous locations into different classes and divisions based on the type and concentration of flammable materials present. The electrical inspectors play a crucial role in ensuring that electrical installations comply with the NEC and other applicable codes and standards. Electrical inspectors review electrical plans, conduct on-site inspections, and issue permits to ensure that electrical work is performed safely and correctly. Working with a qualified electrical inspector can help prevent electrical hazards and ensure that electrical systems are installed properly. Proper labeling of electrical equipment is essential for safety and maintenance purposes. Electrical panels, circuit breakers, switches, and other equipment should be clearly labeled to identify their function and voltage. Labeling helps prevent confusion and ensures that electrical equipment is operated and maintained safely. Electrical safety audits are comprehensive assessments of electrical systems to identify potential hazards and ensure compliance with safety regulations. Electrical safety audits can help prevent accidents, injuries, and equipment failures. It is recommended to conduct electrical safety audits on a regular basis. Lockout-tagout procedures are used to energize electrical equipment before performing maintenance or repairs. These procedures involve isolating the equipment from its power source, locking the disconnect switch in the off position, and attaching a tag to the switch indicating that the equipment is being worked on. Lockout-tagout procedures help prevent accidental energization of equipment, protecting workers from electrical hazards. When selecting electrical equipment, it is essential to consider its listing and labeling. Listed equipment has been tested and certified by a recognized testing laboratory, such as UL, to ensure that it meets safety standards. Labeled equipment bears a label indicating that it has been listed and meets the applicable safety standards. Using listed and labeled equipment helps ensure that electrical systems are safe and reliable. In addition to the NEC, there are other codes and standards that may apply to electrical installations, such as state and local electrical codes, building codes, and fire codes. It is essential to be familiar with all applicable codes and standards to ensure that electrical work is performed safely and legally. Continuing education is essential for electricians to stay up to date on the latest codes, standards, and technologies. The electrical industry is constantly evolving, and electricians must continue to learn to remain competent and safe. There are many resources available for continuing education, such as courses, seminars, and online training programs. Ground fault protection for equipment, or GFP, is used to protect electrical equipment from damage due to ground faults. GFP systems monitor the current flowing in a circuit and quickly interrupt the power if they detect a ground fault. GFP is required for certain types of equipment, such as large motors and generators, to prevent damage and reduce the risk of fire. Electrical drawings and diagrams are essential for planning, installing, and maintaining electrical systems. Electrical drawings show the layout of electrical circuits, equipment, and wiring, while electrical diagrams show the connections between electrical components. Accurate and up-to-date electrical drawings and diagrams are essential for ensuring that electrical systems are installed and maintained correctly. It is also useful to get feedback from other people who has used the Evans bender and see what they have to say as well.